Okay, this is an intro video on one-sided limits. I'm going to talk about polynomial and radical functions, rational absolute value, and then piecewise. Again, one-sided limits. Okay, so for one-sided limits for either polynomials or radicals, if you notice, let's say we're going to pick a point, say right here. Well, notice from the left, from the left or from the right, those two will always agree. So if I pick a different point over here, from the left and from the right, so for one-side limits for polynomials or radical functions that nothing else has been done with them, there will always be a limit. You won't really have one-sided limits unless it's a test and you're trying, I don't know, they're trying to kind of stump you up, but there should not be one-sided limits really for polynomials or radicals. But for rational and absolute value, so a rational, a basic parent graph of a rational function looks something like this. This would be the negative version. This would be a negative 1 over x that I just drew. But notice if we're talking about one-sided, if I say the limit of negative 1 over x as x approaches 0, from the left, and all we can do is look at the left side of 0, well, where is that approaching? That is approaching, that the y values are headed off to positive infinity. And if I were to say, look at that from the right side, the y values are now headed towards negative infinity. Okay, so that's the rational. You will have one-sided. The big idea here is for rational and absolute value, you will have one-sided limits. In fact, those are the most common, and then also piecewise. So piecewise, again, you have the limit as x approaches c, f of x, and f of x is broken down into two functions, a g of x and an h of x. Well, notice there is a gap. But if you say, I want to know what the limit is as we approach c from the left, well, the left is this right here. Remember, if you're looking at a number line, numbers getting smaller go left. So this is from the left side. So we would look at h of x. So this right here would be h of x. And somewhere, anywhere here, it's continuous. So depending on what you put in for c, you're going to have a height. All right. So that's just, well, let me go one more side. So for polynomials one-sided, every single time, it doesn't matter what the polynomial is, it doesn't matter left or right, you are going to have a height, but the right side and the left side agree, so most of the time you're not really going to have this limit. So here's an example. Here's a trinomial. You plug 0 in. So this trinomial would look maybe something like this. I don't know exactly where it would be. It wouldn't really be that, but let's have me move that over a little bit to make that a more plausible. I don't know, could look something like that. I didn't take the time to graph that. But notice from the left and from the right, they're both sides are headed. So we don't really have to worry about one-sided graphs, one-sided limits for polynomials or for radicals. All right, that's it.